I think we can skip to the next. This is just to advertise our website. Yeah, we'll introduce us. We'll introduce ourselves. These are the tables of content that we have. I'll go over real-time analytics that we have in Myntra, how Druid comes into picture in that equation. And then Anshul will cover faction analytics, how tuning is
Can
done.
you hold the mic closer, please?
Yeah,
Don't
sure.
take people.
How tuning is done on Druid for those use cases, and we'll take questions from you if you have any. Can we go to the next slide? Yeah. A little bit about us. My name is Abhishek. I've been working in Myntra for 1.5 years. Uh, I work in Myntra Data Platform under NRT. NRT stands for Near Real Time. We mainly deal with clickstream data, and you'll see how that comes into picture. And
Hey, my name is Anshul. I've been working with Myntra for about 2.5 years now. So I'm also part of Myntra Data Platform, and within that pod, I'm part of the processing pod, which deals with ETL pipelines and then serving that data into platforms like Druid. So I've been responsible for maintaining and keeping up the Druid cluster for about 2.5 years now in Myntra. Next slide.
Next slide, please. Yeah, a little bit about our company. We are the ones who had to change our logo because someone had a little too much time, if you know what I mean. Okay, all jokes aside, Myntra is the best fashion e-commerce of India. I'll go over. Can you go to the next slide? Yeah, I'll go over a bit of scale of Myntra, why we are here on the stage is because of scale. Myntra deals with a lot of customers, a lot of data. To put it into perspective in numbers, we have over 100 million app installs. We have 2.1 million plus styles that we deal with. Uh, we also deal with 6,000 plus brand partners. And we serve all over the country, which covers around 19,000 plus pin codes. A little bit about the Myntra Data Platform.
So at Myntra Data Platform, we are an organization of about 30 people. So we have, as stack, we have Spark, Databricks, Airflow, Druid, MemSQL, Kafka, almost everything which you hear about in the data ecosystem, we have deployed. To talk about scale, we have around 1K data pipelines, 10,000 node Spark cluster, 80,000 user queries. These users are mostly internal users, our business insights team and our leadership teams. We manage petabytes of data in terms of scale. We have billions of clickstream events being streamed into our pipelines from users directly, and we handle millions of transactional events each day. So that's the kind of scale we deal with at Myntra Data Platform.
Now I'll go over what real-time data analytics looks like within Myntra. I'll go over what, why, and how of how all of this happens. First is what. What do we mean by real-time analytics? As I said, I work in NRT team, right? We mainly deal with clickstream data that you can also call it as traffic. So you need to capture traffic so that you know what the users are doing. And then we also need to provide minute level aggregates on various, you can see it, it written as devices and sessions. So these two are two different, like if you know how sessions work, you have normal devices and you have multiple sessions on the device. So two different dimensions to work with. You can think of it like that. So this is the what of real-time analytics. Why we need real-time analytics? I mean, of course, business reasons, but to get into a bit more detail, we need to understand our impact on marketing decisions that are taken. We want to calibrate for higher sorry. We want to calibrate for higher engagement through data analysis. This can mean pushing notifications at the right time, changing price points at the right time, so that we have higher. I mean, engagement covers it's a broad spectrum of a word, but it can mean from retention on the app to purchases. And then you have real-time monitoring during sale events. Sale events see us uh, dealing with data which goes up 2 or 3 times during the sale days compared to other days. Internally, we call it high revenue days. So you want to observe what is happening during that time, and that needs to be real time. That's where this comes in. Next slide. As for how, this is how our current pipeline looks like. This is what I deal with on a day-to-day basis. You have your clickstream sources, which are your websites and your mobile applications, Android, iOS, and other OSs. All this, all these sources, they generate the clickstream data and post it to our internal service called Heimdall. Heimdall is a service written in Go. It currently runs on Kubernetes pods, and it is really low latency and very highly scalable. Currently, we deal with a, so as I said earlier, Myntra scale is what is made us speak here. So that application is able to handle all that. So what that application does is it takes that data, does an initial few checks, and then pushes that data into our primary Kafka. So from our primary Kafka, as any other company, we have Spark processes running. These are streaming Spark jobs, which secondary Kafka. So this is where Druid comes into picture in our case, which is it takes the data from secondary Kafka, ingests it, and makes it available for users to use. In our case, the user just so happens to be Power BI. So you can see there are a few nodes between Druid and Power BI here. That is due to a limitation of Power BI not having a connector for Druid, which is a huge pain. So what we have done is, in order to circumvent that, we have a script which takes data from Druid, populates into MySQL, and Power BI connects to MySQL for that data. Because Power BI is a visualization tool and we know exactly what needs to be visualized there, we are able to do this. But while we are doing this, we are still leaving so much potential of Druid on the table that we are aware of, but we are forced into using Power BI. That's just part of the life, I guess. Uh, Next slide, please. So the real question is, we have all of this, but why did we choose Druid in the first place? I mean, the obvious answer is my manager told me to use Druid. That's why I'm using. But no. As I said, well, I'm part of a near real-time team, right? So we have a bunch of requirements that needs to be satisfied by a platform for us to choose something. That means you want to be able to easily ingest data from Kafka because Kafka is our life. Uh, and it needs to be robust enough and easy enough to readily author your aggregations so that you can import or create new use cases on the go and fast, because time to market is really, really important. And then you have fast data ingestion and fast data recovery, which is another core requirement of NRT. because it's able to ingest data from Kafka. It is really fast. And then you have data querying, which is also in milliseconds, because you're able to get unique counts, which is a really intense, compute intensive aggregate to take out, that can be taken out really fast from Druid. This makes it an easy choice for us. Next slide. Okay, now we know why we use Druid. How do we manage Druid, or rather, I should say, real-time Druid in Myntra? I'll start with how we have deployed Druid in our ecosystem, which is we have supervisory processes running for each node type on VMs, and we have auto restart scripts. Of course, it has not gone down, but you cannot be too careful when it comes to traffic data. So we have auto restart script running on cron, constantly checking whether the process is up or not, and immediately bringing it back up. And we also have, of course, you can't just have it restart. We have monitoring and alerting on that. With that said, we also have Prometheus-based metrics going out of Druid, and we visualize it and apply alerts on through Grafana dashboards. A bit about scale with how much we ingest into Druid currently. Just to preface, our real-time Druid is quite young. It's probably a year old within Myntra. So we currently deal with around 60K records per second. And with that scale, of course, you need to optimize for both cost, I mean, just cost. Like, when you go into the technical terms, you need to optimize for compute and storage. So how we have done that optimization is through those two key points, which is task count and schedules. Task count, your traditional practice is to, because we are dealing with Kafka ingestions, any distributed system that reads data from Kafka, your traditional practice is to have your task nodes be equal to the number of partitions of a topic that you're reading. But we, through benchmarking, we observed that for our use case, that was not needed. It was too, we were just idly wasting compute on the processes. So what we did was to reduce the task count less than the number of partitions that are there, so that we can save on cost. Another is sketches. We use Theta sketches for our unique counts that I mentioned for devices and sessions, right? So in Theta sketch, you have tunability with respect to how much. So you can tune between accuracy and storage. If you read about sketches, it's really interesting. You can, so what we did was we found the right balance between accuracy and size, so that we can reduce on historical nodes required, and then of course the deep storage costs being lower. So this is how we have sort of laid out our uh, uh, Druid cluster within Myntra real time. Next slide. A few hits and misses with Druid that we have had. Of course, hits are going to be your, all the selling points of Druid, but mainly for us, it has been low cost and fast ingestion and retrieval, because near real time. Misses have been with deployment management. So because you have different node types, what happens is you have different configurations that need to go into each node type, and managing that ourselves has been a bit difficult, because each change needs to happen in all the data node types. And then you have, so this is a really big pain point for us, especially because NRT is, you see that word real-time segments, right? So what happens within Druid when you're doing real-time ingestion is you have your segment gets created. It's called a real-time segment until your uh, segment granularity is reached. So let's say your segment granularity is 30 minutes. until the 30 minutes worth of data is stored, it's actually real time. It will keep updating that segment. So because it's continuously updating that segment, your query performance is really bad. It cannot grab that data fast enough and give it back. So that is something we are still trying to figure out a workaround for, because we need to be serving the data within minutes. So this sort of covers our real-time Druid setup. Before I pass on the mic to Anshul, a bit of an inspirational quote from someone famous.
Thank you for that inspirational quote, Abhishek. So he covered our real-time Druid use case. So the cluster I manage that is mostly concerned with a batch system. So we have batch ingestion happening at every day from various pipelines. So I'll be covering what we serve and how do we manage scale on that cluster. So first of all, I'd like to talk about the problem that we are trying to solve. So why do we need a OLAP which serves these many queries so quickly? So it's important for the business to understand what the customer wants to buy. So they want to keep a tab on trends, how the product catalog is changing, what product is in high demand, how many orders, how many views a certain product is getting. So all of these insights are required for business to make key decisions. Apart from that, they also want to plan their next season's assortments, as in what will they sell in the next season is driven by these aggregates. It's important also to get insights on products so that we are when we sell our own internal brands products, we sell them at a competitive price. So those data are looked upon using these aggregates on Druid. So it helps us benchmark for price and for competition at a very fast scale. So Myntra also has business partners in terms of sellers who sell on the platform. So they can also track how good or how bad their products are doing and how many orders they are receiving from certain pin codes, what is the nature of their consumers, and what is the number like on their returns. So all of these metrics are important to serve both for Myntra as a business and also for our business partners, which is why we need a system which can serve these aggregates at speed. So the challenges around this problem are ingesting diverse sources of data. So from our upstream, we're getting clickstream, we're getting downloads from the data warehouse, we have a data lake. So all of these data sources have to be ingested and the volume is large. You need to process all of this data and make sense out of it. So you need to identify which keys you need to map on and what insight you can generate on this various sources of data. Uh, and once you have figured that out, once you have generated that insight, you want to serve that quickly. So those aggregates have to be made available in a very fast manner. And you also need to handle multiple people querying that aggregate. So these are the challenges which we deal with when we start building out such a system. So how do we approach solutioning? So in Myntra, we try to break down the problem, broadly speaking, into three pieces: ingestion, processing, and serving. Next slide. So our tech stack is also organized around these three sub problems. For ingestion, we have Kafka. We ingest from data warehouses, databases. For processing, we have Spark and Hive. And for serving, we use systems like Trinio and Druid. So the system I work upon, so the pipeline for that system looks like this. We have data coming from various users, the product catalog, the orders and the returns come to us via the data lake. We also have events coming from Clickstream, and we process all of that in an ETL pipeline, which is orchestrated by Airflow. And at the end of it, we ingest that into Druid in a batch manner, and we serve this on a web portal that is also a custom made, homegrown portal. So something about the Druid deployment that I deal with. So we have currently migrated from version 0.18 to 26. We have we had in the old cluster we had around 70 data nodes and four query slash master nodes. So you see a great cut down in the cluster size from 70 data nodes to 15 data nodes. I'll talk about these tunings in the next coming slides, but this is how the deployment looks like. So in terms of scale, we are ingesting 150 million rows every day. We have a data retention of 2 years, which means that we allow our users to query data for up till 2 years. We serve 40 million unique product IDs on our data set. The entire size of our Druid deployment in terms of data is more than 20 TB, and we allow our users to in one go, the query can span over 6 months of raw data. So tuning. So I talked about how we cut down the cluster size from 70 data nodes to 15 nodes now. So there have been multiple parts to it. First, the basic thing we did was to increase the disk size on our historicals. So earlier, we were only scaling horizontally the historicals, and we would keep on adding VMs along with the disk. But this time along, we are commissioning for larger machines which have larger disk sizes, so that they're easy to manage, because it's anyway very hard to manage Druid because of the different types of data nodes. And when you add to that problem deployments across 70 nodes, the problem becomes even more challenging. Uh, so apart from cutting down the number of VMs and provisioning larger VMs, something else we've done is to tune our ingestion spec so that the data is also optimally stored on the nodes. So earlier we were not doing any kind of partitioning or indexing on our data, and that had exploded the size of our data sources, and we were forced to use more number of VMs. So we have tried to handle that by partitioning data on dimensions, key dimensions. For example, in our data sets, a key dimension would be marketplace or gender, which a product belongs to, or the category it belongs to. For example, it could be a t-shirt or a jeans or anything like that. So yeah, I've just mentioned the numbers here to give you a flavor of how this tuning has performed for us. So at this moment, in our production environment, we have the data partitioned, and we have bitmap indexing enabled on certain dimensions. And it has significantly reduced our cost of data. Apart from that, we also filtered out much of the data which we realized was not being used in the queries. So this also, I would like to mention that Druid has this great feature of reindexing data from Druid itself, where you can add filters if you want, and you can also partition in place. So you don't need to ingest the data again from the whatever source. you're using maybe S3 or any object store. In our case, we're using Azure, by the way, because I realized that there was a question around what object stores Druid supports. We've been using Azure forever. So yeah, I mean, this was about how we tune the cluster. Any questions so far? I mean, am I going too fast? Please stop me and ask a question. I would like a break.
Any questions online? There's.
It's the previous what slide that I forgot your name. You have mentioned there's a spark in between, right? Primary Kafka and secondary Kafka, right?
Yes.
What that spark does?
The way it is laid out is you have topic separation based on clickstream event in the primary Kafka, and then you have a flattened data coming into your secondary Kafka. So that is what Druid consumes. In the preprocessor, we are flattening data. We are verifying the events are proper or not. Schema checks, all that happens in your preprocessor. But I'm just skipping over other branches of the pipeline which do other things.
It's not pre-aggregation, right? You are not doing any aggregation.
No. Okay. It's just flattening.
I was thinking that is you are doing pre-aggregation before pushing data into that.
Then there's no point in using Druid.
Right. That's why I thought of.
Yeah, true. Yes, we have to. Currently, so one of our one of the highly requested features from our team is multiple topic ingestion into a single data source. So we still don't have a way to do that. So we have to combine previously in the Spark stage and then ingest into Druid.
So my question was around that only, around whether you guys are to support joins of data sources, are you pre-processing it, or are you doing the join on Druid itself when the business analysis is happening? So are you pre-processing the join? Are you like loading in a pre-joined data source, or are you joining data sources in Druid itself?
The traditional meaning of join doesn't really apply here because these are separate events technically. So you're not doing any joins. It's just bringing all the streams into a single stream is what you can think of.
Join support also has come in the later versions, right? Like in versions we were using around 18, there was no feature to join data sources, I believe.
Yes.
So I have a question regarding re-indexing. Yeah, sorry, I'll repeat. I have a question regarding re-indexing, as you mentioned about that. Can you elaborate on the use cases or if any performance bottlenecks you have faced during that?
Sorry, I didn't capture the question. What do you?
So during re-indexing, are you like using it in your pipelines? Or...
Right. So to shed more light on that, so we had a very large data set which we realized we had to prune. So instead of re-ingesting that data again and dropping the older data, you could just re-index and you could use Druid as a data source, and you could add those conditions in the spec itself, and it would handle it internally, and it would be faster than reloading it again from fresh.
But is there any memory issues you have faced because you will be filtering the data, asking Druid to filter it? Because like for us, re-indexing took a long time. We couldn't like really make it work for us.
It took some time because the data set was huge, but we did not run into any memory issues as such. But it took really long, only because the data set was huge. I think it depends on the size of your files. So maybe if the files are smaller, it will be easier.
So the data you are sort of re-indexing is like smaller in amount comparatively.
Large number of files, but each file is smaller in size.
Got it. Thank you.
I have one quick question for you.
This is with regards to the hits and misses thing. So I'm getting an echo. Hits and misses slide. You said there was some problem with real-time querying.
Yes.
So Druid is basically, a system which will allow you to do real-time queries for events that happen like as recently as like just a second ago or even less, right?
Yeah.
So what sort of issues you faced, and why was it a miss for real-time querying?
Because let's say you want to look at data for the last 5 minutes. First of all, your segments are continuously getting updated, so you'll never have the actual data that you're looking for to the right second. Another thing is because it's getting updated, as I mentioned, the queries are taking way too long for us to get that last 5 minute worth of data. If you do it for, let's say, an hour ago, it works fine. Sort of a middle ground that we reached to circumvent this to an extent is look at data for 5 minutes, but look at it only after 2 minutes have passed. That sort of allowed us to find that balance of query timing and real timeness. Of course, our ingestion lag is nowhere close to 2 minutes, but we have to live with it because there's no other way to get that data accurately and quickly as well. Does that answer your question?
Yeah. So I'm thinking there is some sort of configuration thing that maybe because for in many customers we see that it is. I mean, I work for Imply, so we see that this is actually not happening. So maybe there's something in the middle manager or some indexer process timeout or something like that.
I mean, a simple solution would be to decrease the segment granularity, and you will have it running. But that would also mean
that will impact
costs.
the other side.
Yeah. So we are currently logged on this. As I said, we are continuously looking for a solution to overcome this. I mean, I'll definitely come talk to you regarding this. Yeah.
No, Hi, I have a question related specifically to sketches.
Yes.
You said you use theta sketches.
Yes.
How do you deal with the problem of two theta sketches intersecting with a very different cardinality? Let's say one sketch is of 1 million, another sketch is of thousands. What's the K value you use specifically, to be precise?
I think we use 32K for the, I'm forgetting the key value, but you'll see if you look at the spec of the sketch, you'll know what 32K means. As for your first question, we thankfully don't have to deal with that because we have a set segment size. And our queries are very predictable in nature, where the duration or the time period of the query is very fixed. So we have not dealt with that problem at all. So I don't know what a solution would be to such a problem as well.
And you use only theta sketch, you don't run into the problems, or you don't have the queries where you say that, I want to find the count of users who clicked on this specific product, rather than you just get the queries like count of users rather than the number of the clicks of count of the users?
Yeah. So, I mean, dealing with high cardinality within Druid comes with its own problems. So we decided early on that we are not going to tackle it at all. Because, I mean, you need to know the limitations of the system you're working with, right? We made it very clear that we are not going to provide that information at all. We are only going to do this. That's where we'll excel at.
Do you run marketing campaigns on Myntra, like ads and all?
I don't have much information regarding that. So I really can't answer you there.
Thanks.
Yeah, thanks.
The Druid version upgrade that you mentioned from 18 to 26, could you just talk a bit about how you went about it? Was it a one shot from 18 to 26, or did you go multi-step?
Yeah, so it was a one shot shift. We were not lucky to do one version at a time, kind of an upgrade. I think most people aren't that lucky. So yeah, we were forced to do that jump from 18 to 26. It has been very seamless. There are a few changes in how the queries work though. So for example, one of the cases we found that a double data type was being implicitly casted as string when you were doing an aggregation called string last. But that started failing when we moved to the latest version. And one other issue we found was that if you try to select a column which does not exist, Druid will return null values for that column, but it will return the rest of the data. But in the latest version, it will just throw a null pointer exception. So these are some query level issues that we have encountered. Apart from that, it has been seamless, I would say.
And your deep storage remained the same. So you did not lose any data during the upgrade.
Actually, we did a data center migration. So we also moved the data. We completely migrated the pipeline. We did some manual copying work. We scripted that out, but we did not lose any data. We just kept a check on that we had a byte level comparison across data centers, that everything is as it is. So yeah, I mean, that's how we did the migration. I mean, we did not do that switch to the previous meta store and the migration using that route. We did not go that route. We just provisioned a new cluster from scratch, moved the data, and re-ingested it. It was pretty seamless that way.
Thank you.
So we have time for one last question, or if no one has, we can move to the next speaker. Okay, guys, give it up for Anshul and Abhishek. Lovely talk.
You can reach out to us. We have put our LinkedIn profiles at the start. You can reach out to us there, or
cool. Thank you, guys.